Hello, welcome to my week in astronomy, or the things I found interesting in the world of astronomy over the past week or so. And this time I want to talk about MMX, the Martian Moon Exploration mission by the Japanese space agency JAXA, which just this week has been moved to development as an official JAXA project. I'll link to their press release which explains what's going on. So first up, what is the mission? In brief, the plan is to go to Phobos and Deimos, Mars' moons, and land on Phobos to return a sample of its surface. The mission will study the surface of the moons, its shape, features and composition, and attempt to decipher how the moons were formed and how they ended up as moons of Mars, with more detail of course on Phobos because that's where they're choosing to land. There's many reasons for wanting to do this, but the big arguments put forth go as follows. There's a temperature, of course, at which water freezes to ice, and we know that the solar system is roughly a big disk with the source of heat at its centre. So we can get this idea of a distance from the sun where water would condense into ice. And we can do the same sort of calculations for things such as ices of ammonia or methane. It's known as the ice line or the frost line. It varies over stellar lifetime, of course, but we tend to put predictions on where it is as not far further out than the orbit of Mars. Now, why is this important? Well, one well-regarded idea of how Earth ended up with its surface water is that it was brought in by objects from beyond this line. Beyond the ice line, bodies that have ice in them form, perhaps a lot of ice in something like a comet, and they go to Earth. What this means is that Mars acts kind of like, if you think of it as the gateway to the ice line just being further out from Mars, and if we study the objects around Mars we might work out how that happens, how ice from the outer solar system comes in to the inner planets. We still don't know how Mars's moons were formed, but if they were captured by Mars's gravity, that could help explain how water gets from the inner solar system. And if they were formed from a giant collision, similar to our best ideas of how Earth's moon was formed, they could tell us about the early environment from when that collision happened. We should, no matter what, get a better idea of how the moons formed and how water came to the inner solar system. So that's the first bit, but another goal of the mission is to help prepare for any potential manned missions. You see, sending humans to Mars is talked up a lot now as something we want to do in the not too distant future. But one possibility which gets discussed a lot is actually to put the base on one of the moons of Mars. You see, this would be really interesting if we were to set up a base on one of the moons of Mars, because, of course, travelling between a planet, a lot of what you need is fuel to get from the surface of one out of its atmosphere to the surface of other. So there's a lot to be said for putting human bases on the moons of other planets rather than going back to the planets themselves. Just because return journeys, you're starting from a moon. You have a lower gravity to escape from, so you don't need to bring as much fuel for the return journey. There's a big point though, this is the one that I'm personally most interested in, which is sample return from these missions. You see, not long ago, the Hayabusa 2 mission obtained a sample from asteroid Ryugu, and JAXA are using this mission, the MMX mission, to further develop their skill at sample return. I've talked before about why I think sample return is so important, but in brief, we can do far more science when we have the full range of laboratory testing available on Earth than anything we can do when we're limited to the equipment we can send up with a rover or something. Also, in future, I think one of the most important goals of space journeys will likely be to bring back resources which are very rare on Earth, but perhaps common in particular bodies in space. And MMX is looking to improve on the sample return demonstrated in Hayabusa. It's a larger scale of mission, so it should be able to scale up what it can do. And the aim is to take a 10-gram plug of material using a corer. So Hayabusa's way was shoot the ground and collect the debris in a funnel. But because you're trying to use a corer here, you have a larger sample size, 10 grams rather than less than 1. And because you're using a corer, the material you collect is ordered with depth, which can be very helpful. So that's what we'll be doing. Now for what the update means. The mission has moved from pre-project phase to project phase. So roughly, this happens in space agencies around the world. There's far more missions that you want to do than that you'll ever find money to do. So you have various stages of planning to make the best use of the funding that you do have, or at least attempt to. In the pre-project phase, researchers at JAXA will have been looking at the plans and proposals for this mission and others. They'll be analysing the finances of the mission and the schedule, and trying to work out if they want to move the mission to development or drop it and replace it with something else. They're considering the science goals of the mission, how important is it for science and for humanity, and also the ease of the mission. We don't want a mission too easy, but just the pragmatism of how possible it is to get done, and also caring about how the mission fits in with what the space agency are doing already. It's no coincidence that MMX will involve sample return, which is something that JAXA have already been pioneering. By moving MMX to the project phase, JAXA is making its decision. They value the science, they're satisfied with the cost and the schedule, and now what they're doing is going to be getting down to the actual job of designing and building the satellite. They'll have a reasonable design already from pre-project, but turning it into something real that they can launch, making the parts, building the software, setting up communications to ground and how that's going to work. And the plan is then to launch in 2024 of the Japanese fiscal year, which basically means from April 2024 to the next March. And this has nothing to do with science, but I do like the fact that the Japanese financial year begins on April the 1st. Don't put me in charge of JAXA's finances, please, or at least if you do, double check the year's budget the day after. The plan for making travel to the moon easier by strapping it to a winch and pulling it closer to Earth, that may not have actually been approved. But anyway, I digress. There's a planned launch in 2024. There'll be a slight bit of wiggle room to that because the project is still going to be in its early stages, but should be around then. That's all I want to talk about this week. If you want to find out more about the mission, I'd recommend checking out the press release. It's part of JAXA's own site for the mission, which is something that you might think about checking out as well. It's incomplete in a few places, possibly because of the early stage of the mission, but it still has more detail than I'm ever going to be able to put in a video like this. In my opinion, the English translation that they've done for it is top notch, so maybe check that out. Anyway, till next time, goodbye.